So I would like to invite you to think a little bit about your day so far. I guess like all of us, you went to the bathroom this morning, and whatever else you did, I'm not sure if you realize that you have been exposed to hundreds of chemicals. Actually, there's an estimated number of 30 to 70,000 chemicals in daily use in Europe. By the time I'm telling you this, there are probably 20 more chemicals being registered with the Chemical Abstract Services. So we are surrounded by chemicals. We depend on them in our daily lives, but of course also in agriculture and industry. We all assume they're safe, right? They're safe for us, they're safe for the environment. But actually, to make sure that they are safe, we need to do chemical risk assessments. There's an environmental risk assessment to make sure that we don't harm organisms that, for example, live in water. And one of the most often performed tests is the so-called fish acute toxicity test. Now, you cannot imagine, there are millions of fish used in environmental risk assessment every year. So what you do in this test is you expose fish in aquaria to increasing concentrations of a chemical or also water samples, and then you observe the number of dead fish. After 4 days, you basically count how many fish have died. And then you use this number to calculate the concentration which kills 50% of the fish. And this number is used for risk assessment. Now, by the end of the test, you need to certainly kill all the remaining fish. So you can imagine that this is a pretty brutal test. But like I said, millions of fish are used every year for this test. But it's not only the number of animals. In fact, imagine there's a huge volume of water that you need. You need a large amount of chemical to dissolve in this water. And also this water is contaminated, so you have to dispose or clean it in a costly way. Now at Eawag, we have been thinking for quite some time that this is not needed anymore. There should be better ways to test chemicals for their acute toxicity to fish. The solution that we have come up with is actually to use cells of fish. Cells that were once isolated actually from the gills of a rainbow trout. Last year, this test has been approved by the International Standardization Organization as an ISO guideline. So this is really an internationally recognized quality label, and we are very happy that we have come so far. But you must realize that a development like this does not come overnight. It's really a long journey that we have traveled so far, and the journey isn't over yet. And so I would actually like to tell you a little bit about this journey. So you see, our journey actually began some 25 years ago in a cell culture lab at the University of Waterloo in Canada. I just started as a PhD there in the laboratory of Professor Nels Boles, my PhD supervisor. And when I started there, he had just published a publication about the establishment of the cell line from rainbow trout gill, exactly the cell line that we are now using for this assay. So what is a cell line? What had he done? So basically, he had taken a rainbow trout, which served as a donor and basically has given an organ. The organ was the gill. And he put this gill into a culture dish and cut it into little tissue pieces. And then he provided these pieces with medium and the right atmosphere and just waited. Time had to go by. And with time, cells grew out of these tissue pieces. And so he nurtured them further. And after some time, the entire cell culture surface was covered with new cells, which he could lift off and put into 2 new culture plates. And so you can imagine that in this way, you can continuously, permanently culture these cells. And we are still using them in exactly this way today. So, but of course, we had to think of many other things. We ask a lot of questions, So for example, how can we make sure that we can detect the toxicity of a very wide range of chemicals with many different properties? And then how do we expose the cells to these chemicals? How do we add them? How long does it take until we can safely measure the toxicity? And then, of course, also how can we determine the toxicity? Now, for this, we came up with a solution that we use colored dyes, which basically indicate the viability of these cells. And it's very simple. For some of them, you can even see this by eye. So basically, the darker the color, the more toxic the chemical. So after all these developments, we were finally able to do our proof of concept study. So what we did there was that we selected 35 chemicals with completely different properties, and we tested those in the method. And what we could see is that the cells responded to all of these chemicals, which were really little toxic to very toxic. And we could also show that the cells responded basically exactly like a fish. There was only one major exception, and this was for specifically acting neurotoxic chemicals. So our proof of concept study was really successful, and it was also very well received by the community, but also by industry and regulators. But clearly, I would have asked the same questions. They now ask, well, you're the experts. Can other people do the same?
So we started a so-called round-robin study, where we had partners from industry and other research institutions. We trained them, showed them how the method works, and then they took the test to their lab and performed the same test with a set of chemicals. It's not so easy to find partners for such a round-robin study, as there is rarely any funding. So it's not basic research anymore, it's not yet applicable for industry. So we were lucky that we found a lot of goodwill with partners that participated in our round-robin study.
And so we trained these laboratories, there were 5, and then they tested 6 chemicals, and then we compiled all the data and compared them. And what we could see there is that not only could they all do the test and establish and work with the cells, but also the variability within their laboratories and also between all our laboratories was actually very well in line with other such tests. So this was another very important step for the validation, because without this international testing, no assay will ever be approved by regulators. So the news of this round-robin study spread and also its success, and so we were actually invited to submit our test method to ISO, the International Standardization Organization. Now we did this in 2014, and it took quite some steps to further improve the method, respond to comments and concerns, and I'm very honored and happy that Eawag actually supports this type of activity, because it's no longer basic research, it's really transfer into society. And so then last year in 2019, our method was finally approved. It got the quality label of ISO. It's the first method ever to use a fish cell line with ISO. So is this the end of the journey? Well, it's not, and we are quite happy to continue on this journey.
As the gill cell line assay is now standardized, we got approached by people from outside of the institute whether we could test their samples with our methods. And on this background, we funded a spin-off company called Aquatox Solutions, which now offers the gill cell line assay along with other tests for chemical safety assessment and water quality assessment on animal-free basis. Also, we handed in a proposal to the OECD to have our tests validated on this line as well. An OECD guideline would mean an even wider application of the test, especially in the field of chemical testing. And also scientifically, there are more challenges ahead.
We still need serum to culture our fish cells. This is serum from fetal calf. And of course, we wish to also replace this animal component. So we have funding from the 3RCC, and we are now working on a fish cell culture medium that can go without serum.